The foundation of science rests not on an illusion of absolute certainty, but on the willingness to question, explore, and evolve beyond the boundaries of past knowledge. This is precisely what I emphasized during my interview with Peter Doocy on the Sunday briefing of Fox News yesterday. The video is available publicly, and in it I made a rather straightforward but essential argument. The essence of scientific progress is humility, not arrogance, openness to learning, not the rigidity of expertise. Yet, time and again, we see experts clinging to the conclusions formed from their training data, behaving much like artificial intelligence systems whose output merely mirrors the patterns embedded in their datasets. In the case of comet specialists, their training data for decades consisted exclusively of icy, water-rich objects that originate within our solar system. So when something new appears in the sky, something unexpected, unfamiliar, or anomalous, they instinctively force it into their existing categories, even when the evidence may point elsewhere. A perfect example of this reflexive thinking occurred when 3I/Atlas was discovered on July 1, 2025. Instead of approaching the object with curiosity and a readiness to consider alternative possibilities, comet experts immediately declared that it must be a typical water-rich comet, simply because that is the kind of object they have studied throughout their careers. But the universe does not conform to human expectations, nor does it bend itself to the limits of our imagination. When we encounter something new, the responsibility of science is not to cram it into a familiar label, but to examine it with fresh eyes. This is why I argue that humanity's own technological creations, launched into space over the past several decades, must now be a part of the conceptual training dataset that astronomers use when evaluating unusual interstellar objects. If we have already sent spacecraft, probes, satellites, and even cars into space, then the possibility that other civilizations, older and more advanced than us, have done the same must be taken seriously rather than dismissed outright. This idea is not hypothetical. We already have evidence of how easily scientific institutions can mistake artificial objects for natural ones when they rely too narrowly on their previous catalogs. On January 2, 2025, for instance, the Minor Planet Center, which operates under the International Astronomical Union and serves as the authoritative organization responsible for identifying and cataloging space objects, announced the discovery of a new near-Earth asteroid. At first, there was no reason for them to doubt their classification. It appeared to be a small object passing close to Earth, something that fits squarely within their familiar categories. But then, just one day later, officials realized something astonishing. The trajectory of this supposed asteroid matched almost perfectly the orbit of the Tesla Roadster, the car that SpaceX launched into space in 2018 atop the Falcon Heavy rocket as a demonstration payload. Once this realization clicked into place, the object was immediately removed from the asteroid catalog. It wasn't a rock. It wasn't a natural body at all. It was a piece of human-made technology drifting through space, and experienced astronomers had mistaken it for an asteroid simply because it appeared in the sky and fit the broad parameters of their existing training set. This episode serves as a humbling reminder that even experts can misclassify objects when their expectations are limited to what they already know. The lesson is simple. If an artificial object made by humans can fool experts today, then an artificial object made by a more advanced civilization could very easily fool humanity tomorrow. This brings us to the broader cosmic context. There's often a tendency to treat figures like Elon Musk as unprecedented visionaries in the galaxy, individuals so innovative that they appear almost unique. But the Milky Way is unimaginably vast. It contains roughly 100 billion stars like the Sun, and current astronomical evidence strongly suggests that around 10% of those stars host Earth-sized planets located within the habitable zone. If you were to roll the cosmic dice across billions of Earth-Sun analogs, the likelihood that Earth is the first or only planet to produce technology, spacecraft, or exploratory missions becomes vanishingly small. Humanity is new, exceedingly new, compared to the age of the galaxy. Most stars are older than the Sun by several billion years. If life emerged early on those planets and had billions of years to advance, The odds are overwhelming that many civilizations would have achieved technological capabilities far beyond what we currently possess. To put the timescales into perspective, consider our own Voyager spacecraft. Built with 1970s technology, Voyager is currently traveling at a modest fraction of the speeds that more advanced propulsion systems could achieve. Yet even with this relatively old and slow technology, Voyager will cross the entirety of the Milky Way's disk in about 1 billion years, a blink of an eye compared to the galaxy's 13.8 billion-year history. This means that if a civilization had launched Voyager-level probes billions of years ago, those probes could easily have traversed the galaxy several times over by now. And if that civilization were more advanced, capable of producing spacecraft that last longer, move faster, or operate autonomously, then the spread of their technological artifacts throughout the galaxy becomes not only plausible, but almost unavoidable. This leads to an important implication. Interstellar artifacts, whether operational machines or abandoned debris, could have entered the solar system long before humans began searching the skies. Some of these objects might be small, metallic, tumbling, or eroded by millions of years of exposure. Some might look deceptively like rocks or comets, especially to observers trained to see only natural phenomena. The critical question is whether scientists, especially comet and asteroid experts, would recognize these visitors for what they are. And the honest answer, given current scientific behavior, is likely no. If the training data of experts includes only icy rocks, then they will naturally interpret every anomalous object as an icy rock, even when the evidence suggests otherwise. This is not because scientists lack intelligence. Rather, it is because they are human. They develop expertise by studying patterns, and those patterns become mental anchors. The problem arises when those anchors prevent experts from considering possibilities that fall outside their established experience. Artificial intelligence systems exhibit the same limitation. No matter how sophisticated they become, they cannot imagine beyond the boundaries of their training data. If the data set is narrow, their conclusions will be narrow. Humans, however, have the unique ability to expand their conceptual frameworks, to add new categories, and to imagine possibilities that have not been seen before. But this ability must be exercised deliberately. It does not happen automatically. This is why humility is essential, not humility in the sense of self-doubt, but humility in the sense of intellectual openness. It allows us to admit that we might not know everything yet, and that the universe might contain wonders, technologies, and phenomena that our current knowledge cannot explain. The true spirit of science demands that when we observe something unusual, we do not rush to label it based on past assumptions, but instead examine it carefully, consider alternative explanations, and broaden our frameworks. Interstellar objects like 3I/Atlas are precisely the kind of anomalies that should push us to expand our thinking. They are reminders that the universe is full of surprises, and that our scientific progress depends on our willingness to update our models. Therefore, when comet experts insist that every unfamiliar object must be a traditional comet, simply because that is what they have studied, they limit the potential for discovery. They overlook the possibility that the object could be something extraordinary, perhaps even a technological relic from a distant civilization. And given the age and size of the Milky Way, the existence of such relics should not be considered an exotic or fringe idea. It should be part of mainstream scientific consideration. Just as the Minor Planet Center had to revise its classification after mistaking the Tesla Roadster for an asteroid, comet experts may one day have to revise their understanding of interstellar visitors. But that will only happen if we allow scientific curiosity to replace scientific complacency. In summary, the lesson is clear. Science advances when we expand our training data, embrace the unfamiliar, and resist the urge to force new discoveries into old categories. Humanity has already contributed technological artifact to space, and it is statistically inevitable that other civilizations, older, more advanced, and more numerous, have done the same. If we truly want to understand the nature of the objects entering our solar system, then we must approach them with open minds, combine humility with curiosity, and acknowledge that the universe is far bigger, older, and more diverse than the narrow slice of experience upon which traditional comet expertise has been built.